Hello and welcome back to Sudoku Swami's pencil and paper method. In the last lesson, we talked about naked singles and the conditions that create them. So today we're going to talk about their first cousin, hidden singles. When you are solving puzzles with pencil and paper, hidden singles are probably going to be one of the most commonly occurring techniques that you will ever use. So I suggest that you pay close attention to today's lesson. A hidden single occurs when at first glance it looks like a cell has more than one possibility, but upon further inspection, it turns out that there is really only one possible candidate for that cell, which means you can solve it immediately. To find hidden singles, all you need to do is first locate all the instances of one particular digit that are already placed, and then follow the rows and columns containing that digit into all the blocks where that digit is not already placed, and then look in those blocks for a situation where there is only one cell left where that digit can possibly go because of various restrictions. There are two ways that this can happen. The first way looks like this. Notice how these four threes interact with block 3. This one in row 2 blocks these 3 cells, and this one in row 3 blocks these 3 cells. And this one down here in column 7 blocks this additional cell, and this one in column 8 blocks this additional cell. There cannot be a 3 placed in any of those red colored cells, leaving only one place for a 3 to go in block 3, and that is right there, and you can fill it in. And here in this diagram, this 4 up here in row 1 blocks these 3 cells, and this 4 in column 6 blocks these 2 additional cells. This leaves only one cell left in block 2 for a 4 to go, and it's right there, and you can fill it in just like that. Notice that because of the presence of these other digits, the 5, 9, and the 8, it only takes 2 4s outside that block to create this hidden single. This method of finding hidden singles is known as cross-hatching. Let's take a look at a few examples in some real puzzles. All right, here in this puzzle, let's take a look at how the 7s interact with block 5. This 7 blocks these 3 cells, and this 7 blocks these 2 cells. And this 7 down here blocks this additional cell, leaving only one place left for a 7 to go in block 5, and it's right there. Notice how it only took 3 7s to create that hidden single. All right, here in this one, let's take a look at how the 9s interact with block 2. This 9 blocks these 2 cells, and this 9 blocks these 2 other cells. This leaves only one place left for a 9 to go, and it's right there, and you can fill it in. And notice this time it only took 2 9s to create that one. And here in this puzzle, let's take a look at how the 5s interact with block 7. This 5 blocks these 2 cells, and that's all you need. There is only one place left for a 5 to go in block 7, and it's right there. So this time, it only took that one 5 outside the block to create that hidden single because of the presence of those other digits that are helping to block those other cells. Now here are two very handy and very important situations to remember with regard to cross-hatching. Situation A is whenever you see that you have 8 instances of a digit already placed in the puzzle, all you have to do is find the block where that digit is missing, and you will know with certainty that there is a hidden single on that candidate in that block that can be solved immediately, guaranteed. And we're going to call this an 8-ball. Okay? Here is an 8-ball on digit 7. We have 8 of the required 9 7s already placed. We got 1, 2, 3, 4, 5, 6, 7, 8. So that means there is only one block left where the 7 is missing. And here in this diagram, it is block 4. So because these cells are blocked by the presence of these other 7s outside block 4, a 7 must go into this last remaining cell, and you can enter it just like that. It's a guarantee. Here in this diagram, let's take a look at digit 3. We've got 1, 2, 3, 4, 5, 6, 7, 8 threes, okay? And the only block where we need a 3 is block 1. And since all these cells are blocked, we know with absolute certainty that a 3 must go into this cell, and you can enter it just like that. But let's go back. Notice that because this cell can only see a 1, a 5, a 6, and an 8, at first glance it might look like it could possibly be 2, 3, 4, 7, or 9. But we know that it can only be a 3 because all of those red cells are blocked by the 3s. And this is how an 8-ball works. It will always guarantee a hidden single in that 9th block. And situation B, whenever you see that a block has 2 rows and 2 columns intersecting with it that all contain the placement of the same digit outside that block, then you will know with certainty that there is a hidden single on that candidate in that block that can be solved immediately, guaranteed. And we're going to call this a foursome, okay? Here is a foursome on digit 5. Those 4-digit 5s intersect with block 5 like this. 2 rows and 2 columns, all containing the same digit and intersecting with a block where that digit has not yet been placed. And they block all these red cells, leaving only one place left for a 5 to go, and that is right there. And you can enter it just like that. It's a guarantee. Here in this diagram, let's take a look at digit 2. We've got 2 rows already containing a 2 intersecting with block 3. And 2 columns already containing a 2 intersecting with the same block. So that means a 2 cannot go into any one of these red cells, okay? And therefore a 2 must go into this cell because it's the only place left. But let's go back. Notice that because this cell can see a 7, 5, 8, 3, and 6, at first glance, it might look like it could possibly be a 1, a 2, a 4, or a 9. But we know it can only be a 2 because the foursome blocks all those red cells. This is how a foursome works. It will always guarantee a hidden single in the block that is intersected by the 2 rows and 2 columns containing our designated digit. Please note that whenever you have an 8-ball, it will always include a foursome. But of course, it is possible to have a foursome without having an entire 8-ball. Capiche? The foursome is the key. That's all you need. But if you have an 8-ball, then you can be absolutely sure that you also have the foursome. In any event, you should always be on the lookout for both of these productive situations. The second way to find hidden singles is a little harder to see, but it will look something like this. Here in this diagram, let's take a look at digit 5. Now, if you watched lesson 6, in which I described our system of marking candidates, you should be able to see that this 5 in column 3 blocks these 2 cells, creating what looks like a conjugate pair over here in block 1. And we fill these 2 candidate 5s in because we know one of them must be true, right? With cross-hatching alone, there is nothing preventing or restricting the possibility of either one of those candidate 5s. But if you look a little closer, you will see that this 5 down here blocks this cell, and this 5 together block these 2 cells. So there is nowhere else for a 5 to go in row 2 except in row 2, column 1. It has to be the solution to that cell. It is a hidden single. Like I said, finding these is not quite as easy as cross-hatching, but you may want to check for situations like this from time to time. Let's call this side hatching, for lack of a better term, okay? All right, let's go to the next one. Here in this diagram, these 2 1s interact with block 2 in such a way so as to create what looks like a conjugate pair on a diagonal in those 2 cells. And so we fill them in just like that. Neither of those candidate 1s can see another instance of a digit 1 placed anywhere else, so it looks like either one of them could be true at this point, right? But notice that this 1 up here in row 1, column 1 also blocks these 2 cells, and the rest of the cells in row 3 are already filled in. So this candidate 1 in row 3 is a hidden single, and you can enter it just like that. And lastly, here in this diagram, let's take a look at digit 9. These two 9s block these cells in block 6, leaving what looks like 3 possible locations for a 9 to go in that block. Now, when we are solving puzzles, we will normally only be filling in single candidates when they are conjugate pairs. So we wouldn't actually fill these in because there are 3 possibilities. But I'm just doing it here for demonstration purposes, okay? So even though it looks like nothing is preventing a candidate 9 in any one of those 3 cells, if we look a little closer, we will see that this 9 blocks this cell, and this 9 blocks this cell, and this 9 all by itself blocks these 3 cells, not to mention this 9 and that 9. So as you can see now, there is only one place in row 5 left for a 9, and it is right here, and that is a hidden single. Got it? All right, let's move on and solve today's puzzle. Here is a puzzle with 23 givens that will hopefully demonstrate many of the concepts we have been talking about today and in the last few lessons. As I mentioned last time, it's always fun to see how fast we can solve puzzles, but our objective here today is not speed. We'll slow it down a bit so I can fully explain everything. I'm sure there are several ways to solve this, but let's just cycle through the numbers starting on 1 and see what we can find, okay? All right, we've got a 1 here in column 4 and a 1 in column 6, so that means we can enter a conjugate pair in these 2 cells. One of those 2 1s must be true. Now, as we just saw a minute ago, sometimes all it takes is 1 digit to produce a hidden single by way of cross-hatching, but that's not the case here, so let's move on to the 2s. Because of this 2 up here in block 1 and this 2 over here in row 4, we can enter a conjugate pair in those 2 cells. One of those 2 2s must be true. And now, since those 2 2s dominate column 1 and this one dominates column 2, we know we can enter another pair of 2s down here in these 2 cells, okay? And now, because this 2 in row 8 blocks these cells and this 2 in column 7 blocks these cells, we can enter a conjugate pair into those 2 cells. And since one of those 2 2s must be true, that means this one has to be false. So you can erase that 2, and because this was a conjugate pair, you can enter that 2. Now there's only one 3 in the whole puzzle up here, and so there's nothing we can do on that. So let's go to the 4s. Because of this 4 in column 1 and this 4 in column 3 and this 4 in row 7, we can enter a 4 in this cell right there. That's the only place left in that block for a 4. And now there's only one place left in block 8 for a 4, and that has to go right here. And then over here we have a 4 in column 8 and a 4 in column 9, so that leaves only one cell left in block 6 for a 4, and we can put that in just like that. And now if we look up in block 2, this 4 blocks row 3, and this 4 blocks row 2, so we can put a 4 into one of these 2 cells, but there's a 4 down here, so it can't go here, it must go there. And now we have an 8-ball on the 4s. We have 1, 2, 3, 4, 5, 6, 7, 8 4s. So we know we can place this last 4, and where is it? It's going to be in block 5. So these 4s block rows 5 and 6, and these 4s block columns 5 and 6. So the 4 must go in this cell right here, and now the 4s are done. So let's move on to the 5s, and because we have a 5 in row 8 and a 5 in row 9, we can put a conjugate pair of 5s into those 2 cells. One of those 2 5s must be true. And now because of this 5 over here in column 8 all by itself, that means a 5 must go into one of those 2 cells. And now because this 5 rules column 8 and these 2 5s rule column 9, we can put a conjugate pair of 5s into those 2 cells. One of those 2 5s must be true. I think that's all for the 5s for now, so let's move to the 6s. And in row 5 we've got a 6, and in row 6 we've got a 6, which means a conjugate pair of 6s can be put right there. And then because of this 6 in column 5 all by itself, that means one of these 2 cells must be a 6. And now, since they rule row 3 and this 6 rules column 9, we can put another conjugate pair of 6s right here in these 2 cells. Now notice this cell right here, let me mark it. This cell with the 5 and the 6, that is not a bi-value cell, because this cell could be a 1 or a 7. It does not see any 1 or any 7. But we don't put those in there because we want to be as economical as possible. But we know that one of these two cells must be a 6 and one of these two cells must be a 5, but that does not make this a bi-value cell. This cell could be other possibilities. So you need to make a mental note of that and don't forget it. All right, let's move on. So now because these two 6s in row 3 rule that row and these two 6s in row 1 rule that row, we can put a conjugate pair of 6s into these two cells. All right, that's all for the 6s for now, so let's move on to the 7s, and we've got a placement on 7. We've got a 7 in column 1 and a 7 in column 3, so there's only one place left for a 7 to go, and that's right there. Then down here in the lower horizontal chute, we've got a 7 in row 8 and a 7 in row 7, so we can put a conjugate pair of 7s into those two cells. And now because of this 7 in row 4 and this 7 in column 8, there is only one place left in block 6 for a 7, and that's right here. So now we're going to erase that 5, and you can enter this 5 because that was a conjugate pair, right? And because we just put in that 5, that leaves only one place left in block 5 for a 5 because we've got a 5 here in row 6, we've got the 5 in row 4, and we have a 5 down here in column 6. So 5 must go in this cell, and you can put it in. And now because we put this 7 up here in block 1, this 5 blocks column 3, which means we can put a conjugate pair of 5s into those two cells. Again, this cell here is not a bi-value cell, the cell with 5 and 6. It could also be a 3. But we're not going to put that in right now. One of these two cells must be a 5, and one of these two cells must be a 6. And because one of these two 5s up here in block 1 must be true, we know this one cannot be true, so you can erase that 5, and because that was a conjugate pair, you can enter that 5. Now looking at the rest of the 5s, there will be a 5 in one of these three cells in block 2, but because that's not a conjugate pair, we're not going to fill it in. We'll just leave that blank for now. So let's resume the 7s. We've got a 7 in row 1, and we've got a 7 in column 9, and a 7 in column 8, so that means a 7 must go in this cell, which means you can erase that 5 and enter this 5 as the other part of that conjugate pair. And now you can enter this 6 as the other part of that conjugate pair on 6s. And now this 5 eliminated this 5 here in row 1, column 1. So this must be a 5, and this must be a 6. So you can erase this 6 down here and enter that 6. Everyone follow that? All right, let's go back to the 7s. We've got a 7 in row 1 and a 7 in row 3, which means there's only one place left in block 2 for a 7. And now we've got a full house, a natural full house in row 2. This must be a 3. And because we entered this 7 here in block 2 a minute ago, that eliminated this 7 down here in row 9. This cannot be a 7. That was a conjugate pair of 7s. So this one gets erased, and you can enter that one as the other 7 in that conjugate pair. And now we have an 8-ball on 7s. We've got 1, 2, 3, 4, 5, 6, 7, 8 7s, and again, the missing 7 is in block 5. So we've got one in row 4, row 5, column 4, and column 5, so the 7 must go in this cell right there, and you can fill it in, and now the 7s are done. And now we also have an 8-ball on the 5s. We've got 1, 2, 3, 4, 5, 6, 7, 8 5s. So the last 5 must go into block 2, and it must go into this cell right there. That's the only cell left for a 5 in that block. So now the 4s, the 5s, and the 7s are all filled in. It's good to make a mental note when you have placed all 9 instances of a particular digit. That way you can save time by not bothering to look for them anymore. All right, notice up here in block 1 we have 3 empty cells. That means that's a triple, right? One of those cells has to be a 1, one of them has to be a 9, and one of them has to be a 3. But there's a 3 already in row 1, so these can't be a 3. These two cells up here have to be 1 and 9, which means this last cell must be the 3. That's what we call a reduced triple. So now let's pick up where we left off on the 8s. We've got an 8 in row 2 and an 8 in row 3, so there's only one cell left in block 2 for an 8, and you can fill that in. Now we've got only 2 cells left in block 2. It doesn't matter that these 2 cells are empty over here because we're just looking at the block. So these 2 cells must be 2 and 6, and there's already a 2 down here in column 6, so this must be the 6, and that must be the 2. Now we do have 2 cells left in row 3, so that is a naked pair, and what are they? It's going to be, again, 1 and 9, and 1 and 9. So the only thing left for block 3 is a 2, and you can fill it in. Now when we fill in this 2, it erases this 2 down here of our conjugate pair, and this is also a foursome. We've got a 2 in column 7 and column 9, and we've got a 2 in row 7 and row 8. So this must be a 2, and you can fill it in. And now here in column 9, we've got 3 unfilled cells. And what must go in those cells? The 1, the 8, and the 9. But we have a 1 and a 9 in row 8. So this cell cannot be 1 and 9, so this must be the 8. And now we have another naked pair of 1 and 9 in that column. And now if we look in column 4, we only have 2 unfilled cells, so that must be a naked pair, and it has to be 8 and 6. But there's a 6 in row 6, and there's a 6 in block 5. So this must be the 8, and that must be the 6. And you can fill them in just like that. So now let's resume on digit 8. In row 6, we have an 8, so that leaves only 2 places left for an 8 to go in column 8, and we can put them in just like that. That is a conjugate pair. Now, if you're unsure about the reasoning of why I am entering candidates like this, please go back and watch lesson 6 in this series, okay? And now this 8 in row 6 also blocks these 2 cells, and this 8 in column 2 blocks this cell. So now we have a conjugate pair on 8 in these 2 cells. And notice this acts just like an X-wing on these 8s. One of the 2 diagonal sets of 8s is going to be true, and the other set is going to be false. So as soon as we solve any one of those 4 candidate 8s, we will know that the other diagonal one will be true and the other 2 will be false. But at this point, we don't know which ones are true or which ones are false. So let's keep going. Now, because of this 8 in column 4 and this 8 in column 5, there is only 1 place left for an 8 in block 8, and it's right there. So we can fill that in. And now, because of these 2 8s in row 7 and row 8, we can put a conjugate pair of 8s in block 7. Now, these 2 8s act just the same way on these 2 diagonal 8s as these 2 8s over here. So one of these diagonal pairs is going to be true and the other is going to be false, or vice versa. So that means of those 6 candidate 8s, as soon as we solve any one of them, we will know which other 2 are true and which 3 are false. And I'm sure that's going to happen very soon. All right, next here in block 8, we've got exactly 2 empty cells, so we know those must be a naked pair, and they have to be 3 and 9. So now that those 9s dominate that column, there has to be a 9 in one of these 2 cells, and because of this 9 right here, we can fill a 9 in right here in this cell. And now because of that 9 in row 4, and this 9 in row 5, and this 9 in column 2, we can enter a 9 in this cell. So that means you can erase that 2, so the other 2 of that conjugate pair must be true, and you can enter that and erase that 8. And now this 8 must be true, and remember, now that we know that 8 is true, we know the identity of those other 8s. So if that 8 is true, this one is false, and this one is true. And if this 8 is true, this one down here is false, and that one is true, and you can enter that. And now because we entered this 9 in column 1 a minute ago, this cell up here cannot be a 9, it must be a 1. Which means this cell has to be a 9. That was a naked pair. And then we're left with 2 empty cells here in block 4, and these must be 1 and 3 and 1 and 3. That is a naked pair. And now we only have 1 cell left in column 6, and that must be a 3. That's a full house, and that eliminates the 3 in this cell, so this must be the 1, and you can erase that one and enter a 3 here. And now we have 2 empty cells in block 6, so these must be 1 and 3 and 1 and 3, but there's a 3 over here, so this has to be the 1 and this has to be the 3. And by entering the 1 here, that eliminates this 1, so this must be a 1 and this must be a 2, and that 1 also eliminated the 1 from this cell, so this cell has to be a 9, and you can erase the 9 there and enter the 1. And then we had another naked pair in that column, so the 1 is gone from this cell and you can enter that 9. And now that eliminates this 9 from this cell, and this must be a 3, and this cell must be a 9. Then in row 9, we have a naked pair of 1 and 6 in these 2 empty cells, but because of this 6 up here in column 3, this has to be the 1, and this has to be the 6. And now in these 2 cells in block 7, they must be a 3 and a 6, and because there's a 6 here in row 7, this has to be the 3, and this has to be the 6. And so we've got 2 full houses. You can look at this as a naked pair in column 7, or you can look at it as a full house in row 7 and another full house in row 8. So the solutions to these last 2 cells must be 3 and 1. That's all they can be, and the puzzle is solved. Okay, that's going to do it for today. Don't forget to click that red subscribe button and the little bell icon if you would like to be notified of new video uploads. In the next lesson, before we solve our puzzle, there will be a short tutorial on locked candidates, so I hope to see you then. In the meantime, be well and be happy.